the two atoms coming together and forming a compound? Are you good with finding the charges on those two atoms? Yes? Are you good with figuring out how many of each atom you need in there? If I have magnesium, which is +2, and chlorine, which is -1, how many of each would I need? Magnesium +2, chlorine -1. How many of each will I need? Write it down. Just on the side of your paper, you've got a magnesium, it has a +2 charge. Chlorine has a -1 charge. How would I put those together? What would my formula be? Magnesium has a +2 charge. Chlorine has a -1 charge.
Do you mean like the name would be?
No, what would the formula be? Oh, yeah. Chlorine. Magnesium has a +2 charge. Chlorine has a -1 charge. How many of each would you need to be able to put them together? Magnesium has what charge?
Oh,
+2. Chlorine has what charge? -1. How many would you need of each to balance them? You need 1 magnesium and 2 chlorine, MgCl2. You've got to get the charges to balance out, right? So whatever you have in positive, you would have to have the same charge in negative. So you need 1 magnesium, 2 chlorine. What if I had magnesium and oxygen? Magnesium is +2, oxygen is -2. How many of each? 1 of each, so it'd just be MgO, right? Okay, Sophie?
Are you talking about ions and their charge putting together?
If I put magnesium and oxygen together, or magnesium and chlorine together, put those together, the atoms,
You're talking about the electrons?
the electrons, the atoms, they're going to have their overall charge, how they're going to put together. So you need 1 magnesium and 2 chlorine, right? If we did it with oxygen, it would be 1 magnesium and 1 oxygen, right? Are you comfortable looking at the charges and figuring out those ratios? Because we struggled just now. Your yellow sheet yesterday, I had already drawn out how many you knew. If I didn't put those circles there, would you be able to figure out that you needed an extra aluminum or an extra calcium or an extra bromine or something?
Yeah.
Would you have been able to figure it out?
It was just like a little bit.
Would have taken a little extra time, but you could do it? Okay, so yesterday's stuff was all called binary because you're just working with the 2 ions, the 2 different types of elements coming together. Today we're going to start adding in more complicated ones. We're going to add in what's called a polyatomic ion. And anytime that you work with polyatomic ions, poly means many. So poly means many atoms. Together, they have a charge. Those polyatomic ions, when they combine, they create what we call ternary ionic compounds. So on top of today's notes, can you just put the word ternary? You're going to get used to that word, ternary. Polyatomic is the new notes for today. And I just want you to add the word ternary on the top there so you get used to kind of seeing that idea. Alright, so today we're looking at polyatomic ions. Poly, like you just said, is many. Atomic just means atoms. And those many atoms put together are going to form ions still. Yesterday, when we did those bondings, you got neutral atoms. So they weren't charged anymore. They balanced each other out. They got to the point where they were neutral. When we have polyatomic ions, these are many atoms together that are still charged. So they haven't neutralized. They're things that we commonly see together. And so those polyatomics will give you a list of them all so that you can use them. They're things that go together automatically, and then they're going to combine with other atoms. They're going to combine with other things in the periodic table. So what is a polyatomic ion? Polyatomic ion is something that's going to have covalent bonded molecule, just a set group of atoms that are coming together and they have an ionic charge already. Again, poly means many, atomic means atoms, and the ion means that it's a charged particle. So just the very title of it is many atoms together that are charged, many atoms that are combined that are charged. So again, all of yesterday's atoms, they ended up forming neutral combinations. You combined your individual atoms together, they formed ions because they formed an ionic bond. But they started as individual atoms. The atom of potassium combined with the atom of chlorine for our first one yesterday. And they formed an ionic bond because individually each element was now charged, but combined they were neutral. Polyatomic ions, when those individual atoms combine, they leave a net charge. So they've got an overall charge on it. I'm going to show you a couple examples. I would write down just 2 of your examples, just so you have an idea of what they look like. I will give you a list of all of them so you don't have to memorize them. It's like the periodic table. It's something that you'll be able to use and look up and I give you to use on the test. Eventually, some of them are going to be pretty familiar to you because you'll use them often enough. So first one we'll give you as an example is sulfate. Have you heard that ATE ending before? 8? 8 just means that it's combined with oxygen. Most often your 8s will have an O3 or an O4 combined with it. So sulfate has an O4, SO4. That SO4 combined together as a whole, the whole thing has a -2 charge when it's an ion, which means, is it gaining or losing electrons as an ion? It's gaining electrons. So if I drew the valence electrons for sulfate, I would draw 2 electrons on the top, 2 on the side, 1 and 1, because it would have 6 valence electrons. It would want to gain 2. So sulfate as a whole, not the individual oxygen, not the individual sulfur, but sulfate as a whole, SO4, is gaining 2 electrons when it's ionized. Does that make sense? We're looking at a chunk, something that's, as a whole, it's got a charge of -2. On the side of your paper, can you write down oxidation number? It's a term we haven't talked about in here, is it? Right?
Right.
Okay. Oxidation number. Every atom on the periodic table, I shouldn't say every, most atoms on the periodic table have what's called an oxidation number. The oxidation number is just the charge on the ion. So when we were looking at the charges that group 1A has, it loses 1 electron, so it ends up with a +1 charge. That +1 is the oxidation number. So oxidation number is just the charge on the ion. So sometimes you'll hear it referred to as the charge on the ion, sometimes you'll hear it referred to as the oxidation number. It's just a term that we want to start using for you. The more chemical terms we use, the more intelligent you sound. But we have to know what they sound, or what they are. So oxidation number, sulfate's oxidation number would just be a -2. Nitrate, again, that ATE ending just means it's combined with oxygen. So nitrate would be NO3. It would have a charge of -1. Again, I would just write down 2 of them so you've got an idea of what they look like. For your notes, I will give you a whole list, so you don't need to write down the others that I'm giving you. So all of these that I'm showing you happen to have ATE endings. So we've got sulfate, nitrate, phosphate. chlorate, and carbonate. Sorry. So all of those, it's just the ATE ending just means that it combines with oxygen, and it's either O3 or O4. Each of them has their own charge. So NO3 has a charge of -1, PO4 combined has a charge of -3, ClO3 is -1. Those are just the oxidation numbers of the charge that go along with it.
Whatever have a positive charge?
There is one, I know of two that have positive charges. There's one that we'll be using that has a positive charge. All the rest are negatives. So there's only one that we would consider to be a cation that would replace the metal. All of the rest of them, they're negative, so we consider them anions. So when you're naming them, where do they almost always go? At the end, right? Anions. So they usually will combine with the metal and then a polyatomic ion. Very rarely we'll get a positive one that would replace the cation instead. We will only be using one that has a positive charge in class. I know of two that exist. I don't know of any others that exist. I haven't looked specifically for them. I've just seen the two.
What are they?
One is ammonia, and the other one I don't know the standard name. We're going to use ammonia, just as something to do chemical reactions with. The other one I don't know what the standard, like, known form is. Common name, I should say. But it's just a separate one. So these ones, the ending changed to ATE. Some of them you'll see like a bi in front of it, bicarbonate. Some of them you'll see oxide on the end of it. They just have a different kind of root word or a different ending to the names. For ionic bonding, the anion always gets what ending? IDE. So if it's just a standard anion, a negative charge, you change it to IDE. Anything else is going to have some type of different ending. Those are going to be your polyatomic ions. So it kind of gives you a hint of what you're looking for. If you see IDE, it's going to be on the periodic table. If you see 8 or ITE or something else, it'll be on a different list to look at. So if we're looking at trying to get a formula, it gets a little complicated when we have the polyatomic ions. So we want to go through a step-by-step process. Give yourself, put a little star or something on here so that you can watch this process, see how it works, so you'll be able to do it later. We're going to look at what's called sodium sulfate. Just put like a star here so when you're looking for the steps process, you can go back, you know where to look in the notes. So your first step for sodium sulfate would be to write the formula for your metal. Sodium is the first name on there. That would be our metal, because metals are on the left. So our formula for sodium, symbol for sodium is just, you should know this one off the top of your head. Thank you, Na. And then we want to put the oxidation number on there. Where is sodium? What group in the periodic table? 2, yeah, group 2A. So it has 2 valence electrons. What's it going to do? Lose those 2. So what charge would it have? +2. Yeah, so we just have Na with a plus, I'm sorry, sodium's in the 1A. Calcium is group 2. I apologize. I was getting all excited. No, I'm all right. Can you pull out your periodic table though too? Because you're going to need it as we're working through these. We're going to do several examples because these get kind of complicated. Okay, so sodium is in group 1A. Gets rid of that 1 electron. It has a charge of +1. Your second step is going to be to write the formula for the polyatomic ion. Okay? You don't know those off the top of your head. That's something that you would have to look up on a list. I'm going to give you that list shortly. So you're going to write down that formula, and then you'd write down its oxidation number or its charge. Sulfate. Did anyone happen to write that one down? I think that was the first one, right? SO4 with a -2 charge. So you write that down. kind of just collecting your information. You look at your metal, you look at your non-metal. You're looking at your cation, your anion. And when you put those together then, is everyone good here?
No.
Nope, okay. This is fun stuff. When you figure this stuff out, you're going to be very proud of yourselves. Good stuff. Poor Bonnie. Are you going to be here? Okay. Are we good? All right. So we've got our metal, we've got our non-metal, we've got our oxidation numbers. We now know oxidation numbers are the charges, right? So when we look at these two, our next step is to say, okay, what would be a common factor or a common multiple for those charges, those oxidation numbers? It's that question, how many of each of them do we need in order to neutralize it, or to get that neutral number? So if I look at sodium is +1, sulfate is -2, what's a common multiple for those charges? 2 would be, right? 2 would be the common multiple. If you think of 1 and 2, how many sodiums would we need to get up to 2? 2 of them. How many sulfates do we need? Just the 1, right? If we have 2 sodiums and 1 sulfate, our charges will neutralize each other. We get a -2 and a -2, or +2 and a -2 combined together. So we would need, how many of each atom? We would need 2 sodium ions, and we'd need 1 sulfate ion to be able to neutralize that, to get them to even out. So we're looking at those charges, just like yesterday. You've got to find places for those valence electrons. So sodium will give up 1 electron. Sulfate can take 2. So we would need 2 sodium ions in order to fill up our sulfate. So if we write the formula down, you're going to put the subscript underneath. So Na would be Na2, and then you'd have SO4. Na2, SO4. Now a lot of times, your subscript, you're going to have to put multiples of that polyatomic ion. So you could just get in the habit of putting parentheses around the SO4. Oops. Putting parentheses around the SO4. Because that's going to keep that SO4 as 1 unit. You're looking at, if you need multiples, you have to do parentheses around your polyatomic ion. Think of the whole SO4 has a -2 charge. You could put parentheses around there if you wanted to. Either way, if you want to, that's good. We'll go through one example where you have to use them, so you can kind of see what they look like when you have to use them. Do you kind of see the process here? We're going to go through another one. Okay. So you don't have to write down the full steps for the next one, but I want you to go through the process. Write down the steps that you would take as we're going through. Our second one is going to be calcium phosphate. Calcium phosphate. So what's your first step? Write down the metal. The metal is going to be the calcium. Ca. And what's the oxidation number for Ca? Plus 2, yeah. Okay. You good with that? Do not look at the back of this. The back looks like a mess. Don't scare yourself. Just look at the front. The front is just a nice list. Now there are, approximately 70 polyatomic ions that you may be using at any time in chemistry. We are only going to use 25 of them about. Okay, so it's not too many, but it's just getting you used to what's going on with the polyatomic ion. So we've got calcium. We said that that's plus 2. What's our second step? Write the formula for the polyatomic ion. So our polyatomic ion is phosphate. Find phosphate. Find the formula. Find the oxidation number, the charge.
You just want me to do?
Let me just zoom in. Let's see. Down here.
Wait,
it too
here.
close? Too far?
No, it's showing through.
Oh.
It is.
Just that one there, so she can see. So you got phosphate. What's the formula for phosphate? PO4. And then what's the charge? -3. Okay, so we think of PO4 as a whole thing. Its charge is going to be -3. So we've got our information that we're going to do. Ca plus 2, PO4 minus 3. What's the next step? Find a common factor, common multiple. We've got plus 2, we've got minus 3. What would be a common multiple? Common factor? 6. Awesome. Very good. So if our common number is 6, how many calcium would we need to get to that point? 3. How many phosphate would we need? 2. You guys are catching on. So we need 3 calcium and 2 phosphate. Is it making sense? Okay. So now, you know you need 3 calcium. You know that you need 2 phosphate. Write that formula for me. What would it look like?
I don't understand.
Okay, how am I going to write it? Because this one is, I told you, you're going to have to use parentheses here. How many Ca do I need? 3. So Ca, 3. And then? Parentheses. PO4.
And then parentheses 2.
Why can't I just put a 2 here?
Because it looks like 42.
That looks like I need 42 oxygen. Do I want 42 oxygen?
Yes.
No, that's not going to work. So we're going to have the numbers with the subscript Ca3, PO4, 2. Like I said earlier, if you want to do parentheses for every subatomic particle right now, that's fine. Just put it in parentheses. You won't have a problem then when you go to add subscripts. It's not wrong to put it in parentheses. It's just extra stuff. So once you get used to it and don't need them, skip them. But for right now, if you want to put them, that's fine. Michaela?
Where do the charges go? Like, do they just...
Once they're to combine together, they're not charged anymore because we don't need to show that they're charged.
Okay.
So the charges are just the information that we need in order to get that bonding piece, to know how many calcium and how many phosphate we need. It's a great question. Does that make sense though? Okay, and again, you can't put the 2 next to the 4 because then we'd have 42 oxygen. We don't want 42 oxygen. All right, are we good with that? This is the most difficult part of today. You can handle this, then you're set. the next part is about naming those compounds. Naming them, just writing the words. Remember how the ionic bond was super easy to write the name for it? All you had to do was the name, and then the name with the IDE ending. That wasn't easy?
No. Everyone we did, we got it wrong.
How about on the yellow one though?
That's
Yeah,
because
it's
already
already
written.
done.
It was already written, right? Okay, look at these. Are they already done? Do they already have 8 endings? Or 8? Or something else?
Yeah.
So is the tricky part gone? It's the easy part here. Come on, get excited. Naming the ionic compound. K, ClO3. Not potassium chlorine oxygen. I like it, but no. Okay, K is potassium. What is ClO3? Chlor something. It can't be chloride because what does the I mean?
Chlorine.
It's an anion. So it has to be ClO3 something. So you got to look it up. And if you look it up, you write the name of the metal, potassium. You look at the polyatomic ion, which is, like you said, chlorate. That's it. Potassium chlorate.
Done.
Isn't that exciting? Can you handle that?
No, that's pretty hard.
Did I write ahead of start writing
It isn't always easy. All right, we're going to give you some practice ones. What I want you to do is slide your desk together with your desk partner. Caitlin, why don't you come over here? Actually, you just stay right there, like that, right? Okay. Who else? Lloyd, why don't you just jump up with the 3 of you? Perfect, thank you. All right.
Me too again.
We're going to do one and together as a class. You guys move your desk.
Yeah. I don't even know.
SG3, SO42 as a class right now. SG4, SG3, SO42.
I won't.
We're going to name the metal first. Metal is magnesium. Name the polyatomic ion
Ooh.
next. SO4.
Sulfite.
Sulfate.
Sulfate.
Is it sulfate or sulfite?
Sulfate.
Sulfate. Thank you. Hey, magnesium sulfite. Do I have to stick the 3 and the 2 in here somewhere? No. Not with an ionic bond. So it is just magnesium sulfate. Okay? When we get to covalent bonds, you do have to work with these numbers. So enjoy ionic bonds. Ionic bonds work really well, but you have to do the charges for the formula. So we're going to give you some practice with just the naming. That's going to be the easy part. With your partner right now, write down your name. Oh, I'm sorry. I have one more example for you. Sorry, don't write this down.
Pretty sure it's already there.
Sorry. One more example. I get excited. Calcium, CaOB plus 2. Hydroxide, find it on your sheet just so you know where it is. Hydroxide.
Ohio.
I don't see it.
What?
I don't see it.
Got it?
Yeah.
OH for hydroxide. Hydroxide has a -1 charge. Calcium has a +2 charge. How would I put those together? Common multiple of 2. How many calcium do I need? Just 1. How many hydroxide would I need? 2 of them. So again, I look at the common multiple. I'm going to need 2 hydroxide ions. So when I put it together, it would be Ca parentheses 2. Okay. Now, we're going to have you practice with these formulas. Write them down in your notes. Go through the process. This is part of your notes today.
Calcium has a charge of +2.
Okay. Al2, so
Sulfate
2.
has a charge of
Sulfate.
-2.
Sulfate. Sulfate.
So it would have to be 2. You would need 2 of calcium, 1 of
Would you like me to find the end of them? And then
Why
just
don't you
show it to
just
her?
pause it right now,
Pause.
and then we'll flash on the answers?
You pausing? I think I just have to do a whole new video.
Oh, okay.
I can't keep up on this.
Hi, Gabby.
And
So that's taking photo. That's in and out. How don't you have a time to pause? Yeah, I don't see anywhere where you can pause.
I need you.